Trigonometry, Chapter 2, Acute Angles and Right Triangles, Section 1, Trigonometric Functions of Acute Angles, Video 5, How Functions Change as Acute Angles Increase. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. All right. In the previous video, we learned about solving simple cofunction equations. In this video, we analyze the behavior of the trig functions as the angle increases from 0 degrees to 90 degrees. Feel free to pause and read the footnote. To analyze the behavior of the trig functions as theta increases from 0 degrees to 90 degrees, let's set up a convenient triangle. We'll start with sine and cosine, whose formulas are here. Since both their definitions have hypotenuse in the denominator, let's use a triangle whose hypotenuse is 1. Here's a picture of a triangle in standard position whose hypotenuse is 1, adjacent side is x, and opposite side is y. This is actually called a unit circle since its radius is 1. The values of sine and cosine end up just being y and x respectively because of our choice of the hypotenuse of 1. This means to study the behavior of sine and cosine, we only need to study the behavior of x and y as theta increases from 0 to 90 degrees. Although we can deduce that behavior from this picture, I think an interactive demonstration is better. The following dynamic graph is one I created at Desmos.com, a free online graphing calculator with amazing capabilities. Here I have a unit circle. I'm going to turn on the sine and cosine illustrations. As we mentioned a minute ago, when the radius is 1, the x-coordinate equals the cosine of the angle, and the y-coordinate equals the sine of the angle, which is why cosine and sine are on the sides of this triangle. If we rotate this angle, watch what happens to the cosine on the bottom. The bottom side of the triangle is shrinking, decreasing, as the angle increases. And similarly, watch what happens to the sine, the y-coordinate, the right side of the triangle. As the angle increases, the y increases, so therefore sine also increases. So from our analysis of the graph, we can state the following. As our angle increases from 0 to 90 degrees, sine of theta increases in value, but cosine decreases in value. But what about tangent? Where is it in the picture? Well, normally I would just do an algebraic argument, but I want to show you a neat little illustration. Tangent is the ratio of y to x, y over x. Well, where can we see that value in this picture? Right now, the answer is we can't, but with some additional components, we can. Let's see if we can get tangent to be a single variable. Since the denominator of tangent is y over x, if we let x equal 1, then tangent of theta would equal y, allowing us to measure the value of tangent as a y-coordinate. So notice I have a blue adjacent side down here of 1. But fixing the adjacent side at 1 means the opposite side would always emanate from the point 1, 0. So we extend the hypotenuse to meet the line x equals 1. And in this setup, the tangent of this angle is y over 1, which would just be the y-coordinate. So by observing the y-coordinate at the top of the triangle, we can see what tangent does as theta increases from 0 to 90 degrees. So let's go to Desmos and look at it. Turn off sine and cosine. We'll turn on tangent and secant. Spoiler alert. The opposite side of this triangle represents the value of tangent of theta, but the hypotenuse represents the value of secant of theta. And if we were to let this angle increase, we'll notice that the right side of the triangle is increasing and will eventually get really, really large, as is the hypotenuse. So this actually shows that tangent and secant are both increasing as theta increases from 0 to 90 degrees. So we'll add tangent to our list. Now, as far as the other ones, we could just do reciprocal functions, because if one function is increasing, then its reciprocal is decreasing, which means sine is increasing, but cosecant is decreasing. Cosine is decreasing, but secant is increasing. Tangent is increasing, but cotangent is decreasing. If you were to try to memorize all these, there's a pretty clear trend emerging. Only the co-functions that start with co are decreasing, while the others are increasing. So cosine, cosecant, and cotangent are the decreasing functions. Now, like tangent, there are visual representations for secant, cosecant, and cotheta. I'll show without explanation, and I'll leave it to you to verify why these visual representations are correct. So let's go back to Desmos just for a second. We'll turn on the tangent and secant, which we already saw. If you can justify why the hypotenuse of this triangle represents the value of secant of theta, then we can see as theta increases, secant is also increasing. But if we turn on the cotangent and cosecant, they are this picture, which makes sense because the denominator of both of those is y. So we fix the y to 1 and see what happens. The length of the side up here is cotangent of theta. And the length down here is the hypotenuse is cosecant of theta. I meant to put the triangle over here on the bottom left instead of the upper right, but it still does the same thing, showing that both decrease as the angle gets larger. All right, now you try. State which trig functions are increasing and which are decreasing as theta increases from 0 to 90 degrees. Not a whole lot to work on here, so I'm not going to wait too terribly long. If you haven't paused to think about it yet, solutions in 3, 2, 1.